Okay, guys, so we haven't done tangent yet. So this is how to do a tangent graph. So what I would like to do, I wish I had a T-chart, which actually I can use part of it, a unit circle. If I had a unit circle and I start with 0, pi over 2. Now remember what the x and y is. So I go out 1, up 0. This is 0 degrees, but the coordinates is 1, 0. Here it's 0, 1. So if you have your chart to look back at, it's going to be helpful. So when I go to 0 degrees, remember I have to put what this says, sine over cosine. So sine over cosine, this is cosine, this is sine. So sine over cosine, 0 divided by 1 is 0. So you fill in the 0. If I graph it, it's right here. Then I go to pi over 4. Now, pi over 4 is this one on the diagonal. And it's square root of 2 over 2. And square root of 2 over 2, since it matches and we put anything over itself, it becomes 1. Then I'm going to go to pi over 3. Well, pi over 3 is up here. Now, I know I skipped a pi over 6. I get that. This is pi over 3, and I'm running out of room. So over here on the side, I'm going to tell you that is square root 3 over 2. Wait a minute, I'm thinking. It's 1/2 square root 3 over 2. That's what it is. I'm going to double check real quick. I'm going to do sine of 60. I want 1/2. Let me make sure that I am in degrees and not radians. I'm in radians, so I got to be in degrees. Now you can see how to get to degrees. Okay, clear, sine 60. All right, so 0.886. So sine is square root 3 over 2 because it's not 1/2. So let's go back to my paper. Let's see where I was. Yeah, this is correct. All right, so to find tangent, I have to take square root 3 over 2 divided by 1/2. But keep change flip, multiply by 2 over 1. These cancel, it leaves me the square root of 3. Now, square root of 3 doesn't help a lot when I'm graphing this, so I'm going to say that's the same as 1.7-ish. It's in that ballpark. Now, pi over 2 is this one up here, and if I put 1 over 0, it's undefined. All right, so if I go in a negative direction, oh, I never did graph all of these. So this one's going to be 1. This one is roughly 1.7-ish. And that's as much as I know. And then this is undefined. And when something's undefined, it means there's an asymptote. Okay, so if I go back in a negative direction and do negative pi over 4, negative pi over 4 is down here and tangent's negative. So that would give me -1. And negative pi over 3 would give me -1.7. And negative pi over 2 would give me negative undefined. Oh, wait a minute. You can't have a negative undefined. It's just undefined. So if I repeat what I have, this one is somewhere between here and pi. I can't see it. It's so little on my screen. That's pi over 2. So somewhere in the middle here, it's in this ballpark. And then this one is undefined. Okay, so you can take the tangent of, say, 85 degrees. and we're already at 11. So I know the closer I get, the more to infinity this goes. If I do tangent 89.99, enter. I'm at 5,729. Yeah, big numbers, just saying. All right, so let's pull this back up. So what I know happens here is this goes off this way. This one goes off this way. So let's grab blue, and I cannot promise how beautiful my curve is going to be. There it is. And it does something along these lines, okay? So what you're going to find, this is going to be the bottom one again, going to here, and this would have gone out over here on this side. This one would come out over on this side, and that one would have gone back, something like that. Okay, so if you look at the bottom just down below, you get to see what these look like. They are cyclic, they keep repeating, but we are not going to graph every one of these, okay? What I want you to graph is only one of them, the one that goes through 0, because basically it's in the middle, the numbers are easier to work with. So I want you to grab some petty paper, and I want you to reflect this. Is the original graph a function? Yes. Every last one of these passed the vertical line test. Is the inverse a function? Well, I don't know yet. Let's see if I can work on that. So this is going to come out here and to here and down here to here. All right. When you're done, and you could have paused me, when you're done, it should look something along these lines. Okay? Hopefully yours is a little better than mine because I can't do patty paper because it won't fit on my screen. So is the inverse a function? Now, at first glance, it's yes, because it's only this red line. The problem is, and I'm not going to fill in all of these things repeat. This thing comes in like this, crosses here, and goes again. This thing comes in right here, crosses here, and takes off out here. And then the bottom does the same thing. So does that pass the vertical line test? And the answer is no. It fails. But if we only look at the red one, it does. So we are not going to graph all of them. And this one, it's not different. When we graph it with a calculator, we get only the piece we did because we only chose one piece. So it's not. Because we only graphed parts, a part. Okay, what's the domain of this red one? Well, it's all real numbers. What is the range of this one? Well, oh, how low does it go? It goes to pi over 2, but it's not included in a bracket. So let's fix this. And I'm actually going to put a couple of things in here. This could have been written negative infinity to positive infinity and never, ever use a bracket. This goes down to negative pi over 2 to positive pi over 2. And it does not include it because if you remember, this is where, wow, did I ever miss it? This is where we had asymptotes. All right, sorry, I'm very tired. I don't feel very awesome, okay? So we're going to get through this together. All right, so shade in what part is used? Well, we just said right here, it's good from pi over 2, negative pi over 2, until we get to pi over 2. So that's right here. Whoops, I didn't mean to cross the line. So you would shade in right here. Okay, good enough. If I were on the board, I would make it a little better probably. All right. Use your calculator, find tangent of -3, inverse tangent of -3. Okay, so I'm going to do inverse tangent of -3, second tan -3, enter. 71.56 degrees, -71. So let's call that -72. So if this is at -72 degrees, -72 is down here past 60, somewhere in here, -72 degrees. Okay, I probably put it over too far, and that's okay. So I have one where this is a negative. Where else can tangent be negative? Well, if you remember, all stairs take caution. This is where tangent is positive and everything's positive over here. So that means it's negative here, negative here. So that means my other line's coming up this way, and this is -72 degrees, or is at 72 degrees. Okay, so what is this value? Okay, you find it by taking 180 minus 72. All right, what is this value? Because actually this is in the principal value range. This would be okay because my principal value range is a negative. So this would be okay. You've got to pay attention. Had this said between 0, that theta has to be between 0 and 360, which is quite often the case, -72 wouldn't be okay. You would have to take 360 minus 72 to find that value. Okay, just saying. And if you want to double check this, you can always check your answer, 108. Take the tangent of 108. It better be -3. So I'm going to go tangent 108, enter. Look at that, -3.07. So really close to -3. Okay. All right. Back to Captain's Place. Now we've got these in. Let's look at this. This is actually a really simple part. And let's see how quick we can get through this. You know what? Let me do this on a separate video because it may actually work out better. You may want to go back and see the separate ones. So this is a separate piece of paper. So let me stop this and we'll start.